Hello students, this is Exponents number 2 notes. We are starting with our warm-up here of quotient of powers property. So as the warm-up, please go through and pause the video and write out the power as repeated multiplication, meaning 5 to the 4th power means 5 times 5 times 5 times 5. Okay, go ahead, pause the video and do that for the rest of these. All right, here is your repeated multiplication, just writing it all out. Like I said, today we're dealing with division, properties of exponents, and 0 as an exponent. This is Exponents 2. So activity number 1, we're completing this table, so we're writing out our repeated multiplication on what 5 to the 9th power means, what 5 to the 6th power means. So we're looking here, and we have 5 to the 9th power, and we have 9 5s up here, and then down here we have 6 5s. Okay, and over here, this is what it equals. Because if you look at this, 5 over 5 cancels, 5 over 5 cancels, 5 over 5, 5 over 5, 5 over 5, 5 over 5, and we're left with 5 to the 3rd power on top divided by 1 as a placeholder on the bottom, which equals 125. So go ahead, pause the video, and write out your repeated multiplication with all of these numbers. All right, so we have our repeated multiplication all lined up here, and then we can start canceling. 5 over 5 cancels, those 5 cancels, and we are left here with 5 squared over 1, and 5 squared we know is 25. Next, we can cancel out our negative 2's here, and we're left with just negative 2 to the 1st power over 1, so we just get negative 2. And now the a's. We can cancel out these a's, and we're left with all of these on top here. So it's 1, 2, 3, 4, 5 on top, so a to the 5th power over 1, which is just a to the 5th power. So we want to use our inductive reasoning here to write a general rule for multiplying two powers that have the same base. And actually we're dividing, so let's change this word here to say dividing. So if we look here, look what happened over here, 5 to the 9th divided by 5 to the 6th, and it gave you 5 to the 3rd power. Over here, 5 to the 6th divided by 5 to the 4th, and it ended up giving you 5 to the 2nd power. Negative 2 to the 5th divided by negative 2 to the 4th gave you negative 2 to the 1st power. A to the 8th divided by a to the 3rd gave you a to the 5th power. So I want you to think about that. Let's make a connection between what happened over here and how our numbers we got for the final exponents over there. Pause it and try to see if you can get it. All right, now that we have paused it and thought about it for a minute, maybe you notice that you are subtracting the exponents. So when we get down here, a to the m power divided by a to the n power, in order to get my final answer, we would take m minus n to get your final exponent. So when you are dividing powers that have the same base, the rule that we're going to use is subtract the exponents. So this will give us a to the m minus n. So our example here, we have a to the 7th divided by a to the 3rd. Now, there should be one more a on here, I believe. So you can cancel these out. There's one a, 2 a's cancel, 3 a's cancel, and we're left here with 4 a's, or a to the 4th power. Or instead of having to do this long written out process, we know that we can just subtract the exponents, 7 minus 3, top number minus bottom number, to get a to the 4th power. So let's do an example here. Let's look at example number 1. We have 2 to the 6th divided by 2 to the 4th power, and that ends up giving us 2 to the 6th minus 4. So you take 6 minus 4, which is 2, so you get 2 to the 2nd power, and we know 2 to the 2nd power is 4. Okay, we can come down here and do this one. Negative 7 to the 9th divided by negative 7 to the 3rd. we get negative 7 to the 9 minus 3. And then here, I can do negative 7. 9 minus 3 is 6, so we get negative 7 to the 6th power. And I can use my calculator to help me with this one because it ends up getting to be a really big number. And negative 7 to the 6th power is 117,649. So I'll change that here. So I would not expect you to do that in your head. Then we have our letters down here, our variables. H to the 7th divided by h to the 6th is the same thing as saying h to the 7th minus 6th power, or just h to the 1st power, or just h. Example number 2, simplifying this. We now have multiplication and division in this problem. So let's do the top part first. Let's simplify our multiplication on the top. 3 to the 4th times 3 to the 2nd. I know that when I do multiplication, I add my exponents together. So on the top, 4 plus 2 is 6. So I'm going to get 3 to the 6th power divided by 3 to the 3rd power. And now I can subtract those exponents. So 3 to the 6 minus 3, which is 3 to the 3rd power, which gives us 27 as a final answer. Example number 3. Taking a look at this one here. We have 12x to the 5th divided by 24x to the 2nd. 12 and 24, those are regular numbers. Those are not exponents. So we still want to divide and do 12 divided by 24. And so if you simplify this fraction here, 12 goes into 12 once, 12 goes into 24 twice, so this simplifies to 1/2. So you're just reducing that fraction. And then x to the 5th divided by x to the 2nd, you end up subtracting those exponents, and so you get x to the 5th 5 minus 2, which gives you x to the 3rd power. So your final answer will be 1x to the 3rd power divided by 2. Go ahead, pause this video here, and try these 3 on your own. Alrighty, so here we go. 4 to the 6th divided by 4 to the 3rd, you subtract the exponents. 6 minus 3 is 3. 4 to the 3rd power is 64. This one is kind of a difficult one. You have multiplication and division happening. So let's combine the top first. Remember, when you multiply, you add the exponents, and we get x to the 7th power on the top. Then we have x to the 7th divided by x to the 4th. You subtract those exponents, and so you get x to the 3rd power. For this last one, do this in 2 pieces. The regular numbers here, 30 and 10, we can actually divide those. 30 divided by 10 is 3. M to the 18th divided by m to the 8th, right here, we subtract those exponents and get m to the 10th. So our final answer, you put the 2 together, 3m to the 10th. Next one, if we take a look here, we have n to the 5th divided by n to the 5th power. So we go through and we do n to the 5 minus 5. Well, we know 5 minus 5 is 0, so we get n to the 0 power. So next we need to talk about what happens when you get a 0 power. 0 is one of those numbers that sometimes things change a little bit. So if we look down here at activity number 2, let's use our calculators and go through and figure out what is 5 to the 5th power. Okay, so 5 to the 5th power, and type that into your calculator, and then do 5 to the 4th power and find and fill in these here. Pause the video to find those. So here's what you get when you use your calculator. 5 to the 5th power, 3,125. 5 to the 4th, 625. 5 to the 3rd, 125, 5 to the second, 25, 5 to the first, 5. And 5 to the 0 power actually gives you 1. Notice the pattern here that you end up dividing by 5 to get to the next number. So getting an exponent or answer of 1 here makes sense because you would divide by 5 and get 1. So on your own here, looking at this next part, we know that 5 divided by 5 is 1. 12 divided by 12 is 1. When you divide something by itself, or the same thing on top and bottom of your fraction, you get an answer of 1. So it's going to be the same thing with our exponents here. 2 to the third power divided by 2 to the third power. You end up doing 2 to the 3 minus 3. 3 minus 3 is 0, so you get 2 to the 0 power, and realize that this is 1. You had the same thing on top and the same thing on the bottom. So we're going to look here, 0 as an exponent. When you get 0 as an exponent, no matter what the base is, so no matter if it's an A, if it's a number, anything to the 0 power is going to give you an answer of 1. So anything to the 0 power equals 1. So taking a look here, these are on your own. You're trying to figure this out here. I have this little cartoon up in the left or right corner here. If you're happy and you know it, clap your hands. I like to think about exponents as little T-Rexes with little tiny baby arms. They can only grab onto what's right next to it. So like for number 1, for example, we get here that m to the 0 power is 1 because m is getting raised to the 0 power, so it's 1. But number 2, only x is to the 0 power. This is saying 3 times x to the 0. So only this piece turns to 1. So this is really 3 times 1, so your final answer is 3. That's what I mean by exponents have little tiny baby arms. They can only grab onto the thing that's right next to it. It can't reach over and grab this 3 also. It's just the x that has the exponent. So then 3 to the 0 power, this piece right here is 1. The x is just there, so our answer is x. And now this one, the 0 is holding on to the parentheses. So everything in the parentheses has an exponent of 0. So this whole piece has an answer of 1. Check out the other videos if you have questions. Work on your homework, do the best you can, and I'll be available to answer questions if you have them.